Hello, my name is Walter Unglob, and this is how to calculate molarity knowing the volume and molarity of two substances. So let's consider a scenario where I have two different substances in two separate containers, each with volumes V1 and V2 respectively, and the substances have molarity capital M sub 1 and capital M sub 2 respectively. So first, we need to understand what these capital M's stand for, what they mean. Well, if we have 1 molar solution, that's equal to 1 mole of that particle species that comprises the substance divided by 1 liter, which is the volume that contains 1 mole's worth of particles. And thus, this is equal to 1,000 moles per meters cubed, if you wanted to use meters cubed as the unit for volume. Now, if we multiply the volume then with the molarity, we end up with the number of particles, or the number of moles, which can give us the number of particles in the substance. So here I have calculated the number of moles for substance 1, and I do the same for substance 2. So I have this many moles for 1 and this many for 2, and when I add them up, I have the total number of moles in the system. So if I want to calculate the molarity of the overall solution, if I were to mix them together, I would first have to add up the volumes to calculate the total volume. And as per the definition, I simply divide the total number of moles by the total volume. Thus, my final molarity for the mixed solution is equal to the total number of moles, N3, divided by the total volume, V3. And in terms of the initial given constants, this is simply equal to M1 V1 plus M2 V2 divided by V1 plus V2. And thus I've calculated molarity knowing the molarity and volume of the two different substances. My name is Walter Unglob, and this is how to calculate molarity knowing the volume and molarity of two substances.